what we propose will work, and is the degree of successful. And then the product will be available to the market pretty soon. And in here is our early generations of our collar design. If you compare this one with this one is developed using some kind of fabric. But this one, we have the steel plate put in. It's a metallic design. One of these collars is costing us £1,000 for this design. And this design, since it's metallic, at first we thought it should be better. But that's not the case. After we put onto the count, within 1 week of the collar is broken by the count. It's no use if we put on some kind of metallic solid thing onto the count. It won't last. The cow is heavy and they are very, if they want to be violent, they can be very violent. They are strong animals. And to come up with a proper collar design is another heavy investment to go through different phases. Here is a picture of our trough. We have the count, have a collar. On the left-hand side is one of our the base stations, the visible design. And then we have our front piece. This is the PCB board. We have radio chip, accelerometer, microcontroller, and then the antenna we use is a patch antenna. This one is the AI challenge, the difficulty to come up with a good AI model, which I previously have mentioned. And here is one of the summary. What we can prove to you is what we propose is actually working. We collect the data, we monitor the count. This count actually shows different activity, and then when it is spike up, when it's increased, it shows that the count actually is agitated by the infections. Right? In here, in this slide, what we say is we have two counts. We have to compare with two counts. Both of the count we can pick up, we can identify from the data they are sick, yeah? From the data we receive. And then we also, this is the first step we use. We collect the data. It's the first step into the AI development. If you couldn't see something in this early stage, then we might have some problems because the sensor will not pick up abnormal activity of the count. Then we need to change the strategy. But in the very early stage, we identify that when the count is sick, we actually can see different sensor reading. That's crucial. This is one of the slides we use to convince the ITI to keep the project going. Here's some of the challenges. These challenges also represent some of the challenges.
I'll just ask about the previous slide. Does this mean that if we look at animals on the count, can we compare for other animals? Does it really apple to apple, or we have to do the same thing, do the monitoring for other animals? Then
in here, what we say is we constantly monitor the count, individual count. We have the historical data. We know the normal amount of activity of this count. And then we see there is a sudden increase of movement because the count of the infections It's very not comfortable, so it's moved a lot, agitated. Therefore, we can pick it up. All right. Actually, this have two count. Both case has been successfully identified. That's what we say. And then what you mentioned have a very good point, because count is like human being. They live in a group. Each individual count have their own position, have their own status in terms of the host. One of the count will be a big brother who will lead the host. All right. Some of the count maybe has been bullied. It tend to stay further away from the host. This kind of thing will impact on the activity, on the amount of drugs they eat when they are outside. Because usually those count have a good status, have a higher position, that tend to get the nicer drugs. All right. Those count with bullying, they tend to eat what has been left over by other count. This kind of thing will have the whole impact. The whole study of this project, put it in this way, the whole project is 6 million pounds. We spent 4 million into understanding the count. You know, that will be your main investment if you want to do this kind of activity. You want to do this kind of research. As I say, put some kind of sensor into the collar, and this collar put onto the count can be done in 2 ways. Yeah? Temperature sensor, even you want to measure the gas given out by the count. Right now, what they are trying to study is the gas generated by the count. Alright? Can be done easily. But this kind of sensor reading, is it going to mean anything? Is it going to be useful for your monitoring system? It's totally another issue. You have a reading? Yes, I have 10%. The reading is 10. So what is going to tell you? They have a clear cut. This one is different from the jungle wildfire monitoring. Wildfire monitoring is quite straightforward. You detect a 50 degrees C, the chances is the fire is already there, right? You no need to have a professor to tell you this reading inside a fire object. You no need that. That's quite straightforward, alright? But for this count monitoring, or for quite a lot of different sensor level applications, you need to look into those. What is the data means, those issues. Yeah? Therefore, it's 2-way. One is the infrastructure, the device development, and then the communications, and then the understanding the data and artificial intelligence.
This is a question on the AI implementation. You see that the AI is done on the sensor platform. So that means every caller, everyone has some AI implemented into it. Guess my question would be, why not have a centralized AI platform rather than a distributed one and reduce the load application for power consumption?
I think I didn't mention it, make it clear that when you have a proper AI developed, the data sent out by individual count is very limited. It just tell you, I am sick, I am okay, that's it. The 8 megabyte is when we try to get the fundamental data to understand the count behavior. That's why we have a lot of data flowing through. What you mentioned is why we need to put the AI modules on the count